Hello, I welcome you all. The problem reads, determine the horizontal and vertical components of a force which the pins at A, B, and C exert on member A, B, C of the frame. Right. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to determine the horizontal and vertical components of the force for which the pins at A, B, and C exert on the frame ABC. Right. So to start with, we're going to draw the free body diagram quickly and then find the support reactions. After that, we're going to dismantle this particular frame. So we have a roller at A, so we just expect one reaction force, AY. We have a hinge at E, so we expect EY, like so, and then EX. So let's take moments about E, so say summation of moments about point E equal to 0. Alright, in that manner. So what we have minus AY, by 3.5, right? Minus AY by 3.5. And then we have anticlockwise plus 400, this is anticlockwise, right, by 2. And then what else? Then we have plus 300 by 3.5 plus 300 by 1.5 is equal to 0, right? AY is negative by 3.5, 400 is positive and clockwise, and 400 by 2, 300 by 3.5, and 300 by 1.5. Alright, I think we have everything. I guess I've not missed out anything, right? So AY therefore is going to be equal to, let's grab your calculators. We have 400 by 2 plus 300 by 3.5 plus 300 by 1.5, then divided by 3.5. So we have a 657.14 newtons. Let me redo this. 400 by 2 plus 300 by 3.5 plus 300 by 1.5 and divided by 3.5. So 657.14. Right, okay. Then summation of forces in the Y equal to 0 in that manner, like so. So what do we have here? I mentioned we have EY, right? We have AY minus 400 plus EY equal to 0. We already calculated what AY is. Therefore, our EY is equal to, so we have a 657.14 minus 400. So EY is equal to minus 257.14. So EY is just going to be in the opposite direction. Right, and then we have summation of forces in the X equal to 0. What do we have? We have minus 300 plus EY equal to 0. EX equal to 0. Therefore, EX is going to be equal to 600 newtons. Okay, so let's write this. So of course maintains ex maintains is 600 newtons. Ay direction changes. Ay is going to be equal to 257.14 newtons. Ay, the same direction, is just 657.14 newtons. Alright, so let me get rid of this since I need this space. I need this space. We now want to find the reactions, the components, horizontal and vertical components at pin A, B, and C. So what we need to do now is to dismantle this particular frame and use the components that are necessary. We don't really need to use all of them. We can dismantle those that we wish or we think can be of help. So for me, I'm choosing member CD. It will be helpful. So let me draw a free body diagram for that. So this is CD. So I have a force here which is a 400 newtons. And then let me say here I have a reactions like so CY and another one like so CX. And then at D, let me also assume I have a reaction like this dy, then I have a reaction like this dx. Okay, so there we go. What do we have? We have 1.5 meters and then 2 meters. Okay, of course for this particular member we only have a vertical force. Okay, just a vertical force. So let's compute our horizontal, let's compute our vertical components, right? So I'll take moments about C, summation of moments about point C equal to 0, like so. So what do I have? I have a 400 minus 400 by 1.5, then plus dy by 3.5 equal to 0. Therefore, my dy is going to be equal to, so it's 400 by 1.5 divided by 3.5. So I have dy equal to 171.43 newtons, right? 400 by 1.5 divided by 3.5, 171.43. All right. And then summation of forces in the y direction, like so. So I have my cy minus 400 plus dy equal to 0. I've already calculated what dy is, so we just replace it there. And if we did so, we're going to calculate our cy. Our cy, what we get? Our cy is going to be equal to 171 is dy, then minus 400, we get cy is equal to 228.57 newtons. All right, so this is interesting. So with this information, we are now going to concentrate on, since we have the reaction at C, only the vertical one. So what we need to do now is to draw the free body diagram for ABC. So it will look like this. It's a free body diagram for ABC. Here I have found my CY. If we had assumed CY like this, so the other one is going to come like this. So CY, we say it is 228.57 newtons, and then Cx is going to be like that. And then we have point B here. Point B, we have let's say we have two members, BD and BE, and these two members are two force members, so we only expect an axial force in each one of these members. You can assume whichever direction you want to assume. For me, I'll assume in BD is in a compression. If it is not, it's going to give me a correct value as I do the calculation. And then in BE, I'm assuming it is in BE is in tension, and we have the slopes that I want to just indicate here. The slopes for BD, I have a run of 3.5 and a rise of 2.5. Okay, and then let me calculate the hypotenuse. So I have root of 18.5. So the perfect root. So 2.5 squared plus 3.5 squared, 18.5. Right. And then for BD, let's check for BD. For BD, I have the run of 3.5, the rise of 2.5. They have the same values, right? So this is also root of 118.5. Okay. So we expect components here. One component like this, another component for this one like this. Okay. So this one is BD by 2.5 divided by root of 18.5, and this one BD by 3.5 divided by root of 18.5. Then we have another component, which color do I use? Green. Okay, like this, and then like that. So this one is BE by 2.5 divided by root of 18.5, and then this one is BE by 3.5 divided by root of 18.5. Okay, and then we have this point here. This point here, we already found our reaction here, so we expect this at this point here to be the same at A there, right? So let's assume this is our A here. So it will be the same value here throughout, 657.14 newtons. All right. So we don't know what Cx is, but we can calculate it from this member. This point is C, B, A. So if we took moments, let me close this part. All right. If we took moments about B, we say summation of moments about point B equal to 0 and clockwise being our reference. We realize that Cx is going to be equal to 0, right? If we took moments about point B, Cx is going to be equal to 0. Okay, Cx times, what are the lengths here? We didn't put the lengths. The lengths here, they are just 2. So this distances here is just 2.5, right? And then also 2.5. Yeah. So Cx is equal to 0. And if Cx is equal to 0, therefore it means dx is also equal to 0. Okay. We've seen this Cx is equal to 0. If this Cx is equal to 0, because we found this Cx equal to 0, it means dx also is equal to 0, right? Yes. Okay. So now we have this issue here. So what we need to do now, we concentrate on just joint B. Joint B. So we know that if we are to just get joint B, this joint B, we can sum up the forces here. Alright, or just the way it is, we just apply the equations of equilibrium, it's just still fine. So we have two unknowns, so then we have three equations of equilibrium, but of course the moment is not giving us anything, therefore we are just going to concentrate on the summation of forces in the x and in the y. So now let's do that. Let me delete this part there, it's messing up. I write it properly. So we said this is Cx, and we said it's equal to 0. Alright, so now let's say summation of forces in the x. So summation of forces in the x equal to 0. Okay, positive like that. So what do we have? We have BD. We have BD 3.5 divided by root of 18.5 minus, BD is minus itself, plus BE 3.5 divided by root of 18.5. Okay, what else? This is equal to 0. Therefore, our BE is equal to BD. Okay, which is cool. So then summation of forces in the y direction. Summation of forces in the y direction equal to 0. Okay, what do we have in the y? We have a minus 228.57. Then we have a minus BD by 2.5 divided by root of 18.5. Then what do we have? Then we have a minus BE by 2.5 divided by root of 18.5. Then we have plus 657.14 is equal to 0. So since we know what BD is, we just replace where we have BE, we replace it with BD. We replace it where we have BD. Okay. So if we did so, then we can find that our BE, we can calculate our BE directly. So let's do so. So we have a minus 228.57. Then plus 657.14. Then we can divide this by a 5. We can divide this by a 5 divided by root of 18.5. So we have a 3, 6, 8.67. Okay, newtons. Let me just come again. Minus 228.57 plus 657.14 and divided by 5 divided by root of 18.5. So we have a 3. Come on, I'm getting a different answer. Sorry about that. Where did I go wrong? Minus 228.57 plus 657.14 divided by 5 divided by root of 18.5. Okay, so this one is equal to 368.67. This is the same one, right? The same one. So we found this. So if we find this, it also means BD is going to be equal to 368.67 newtons. Let's calculate what By is. By at that point is going to be equal to minus BD 2.5 divided by root of 18.5 minus BE 2.5 divided by root of 18.5. And we know what By is. So if we calculated it, it's giving us 368.67 by 2.5 or just by 5 divided by root of 18.5. So this gives us a 428.57. Of course, it's a negative. Just shows that is for that particular member is pointing downwards. 428.57 newtons. And Bx at that point is minus Bd 3.5 root of 18.5 and plus Be 3.5 divided by root of 18.5. And this, of course, we know that Bx, these are the equal and opposite, they are just equal to 0. So let's write a summary of the solution. So we know to start pin A. At pin A, we only have one value, which is Ay. Ay is equal to 657.14 newtons. And then at B, we have Bx. I will not put any signs, okay? I'm just putting the magnitudes. We don't need signs for these particular points because it depends on which member you are looking at. So Bx is equal to 0 newtons. And then you have By is going to be equal to 428.57, and then you have Cx is equal to 0 newtons, and then you have Cy is equal to 228.57 newtons. Right. So basically this is about it. This is the summary of the solutions, the horizontal and vertical components of forces at pin A, B, and C. I hope the video was helpful. If it was, give me a thumbs up, like my video, continue subscribing, and share my videos. Bye bye, and see you in my next screencast.